So anyway, today what are we here to talk about? I'm going to be talking about the SPL, the standard PHP library. If you're not familiar with it, it was released with PHP 5. It's grown a lot since its initial release. There was a lot, there was actually not that much in the original release, but every release of PHP has been adding more and more to it. It's a standard set of interfaces and classes that were built to come in there. And the idea was they're meant to sort of help you solve standard problems and provide efficient data access. Basically, there were a lot of problems that in PHP people were having to solve. All of PHP's libraries, the massive list when you go into documentation for PHP.net, there's all these libraries in there, and all of these libraries do wonderful things, but none of them were really originally designed for the object-oriented nature of PHP 5. There were a lot of common tasks people needed to do. For example, like if you needed to handle a linked list kind of concept or do heap memory management kind of thing. Those were some common things that a programmer might need to do, but there was not a standardized library and a standardized way that all PHP programmers could use that, could do that, and share code and know that it was done together. Unlike some other programming languages that come with very full-featured libraries that handle kind of everything for you, and everyone who's going to make a linked list is obviously doing it the same way. So that was the goal that SPL set out to solve, was let's provide standardized solutions to these common problems that almost all programs, or commonly programs, have to do. I'm not sure how many of us ever really have to do a heap memory sorting, but if you ever need to, there's now a library for that. So there's a lot of different stuff in SPL. There are data structures. I was talking about the stacks, queues, heaps, linked lists. There's all the iterators, which we will be getting into in this talk. Also, if you are not familiar with it, there is a drinking game that comes with iterators. Every time you hear iterator, you need to take a drink. If you did not bring any drinks with you, take count and make it up to later tonight. There's a lot of sort of standard objects like file object and array object that let you handle a file access or arrays in an object-oriented fashion easily. There's a subject observer interface, there's a bunch of exceptions, and there's a bunch more. More keep getting added to it with every release, like I said. So in this talk, we're going to be talking specifically about some of a core set of features that are really useful for any data access object that you're creating. If you have data being stored somewhere in a database, in a cache layer, in files, wherever, and you're wanting to be able to access that data, there's a set of interfaces here that really make it easy for you to do that and in a standardized way. And specifically, it's iterators, ArrayAccess, and Countable. And we'll get into a few other things also as time permits. So the first question is, why would you even want to do this? Okay? Obviously, there's lots of ways you can access your data. The main reason to do this with SPL is that it really allows your user space objects to be treated like a native first-class type. Okay? You're going to be able, as you see as we go through this, to take your own object you created and have PHP operate on it natively, for example, in a for-each loop, without you having to sort of hack around that. So to do this, we're going to go ahead and sort of walk through an example. I'm going to use some sample code, and then we're going to walk through modifying it and enhancing it as we go. So let's start off with the features we're going to want to duplicate here. And these are the features that are natively built into arrays in PHP. As PHP programmers, we're always using arrays. Arrays are sort of the core, anything and everything of PHP. Most objects use arrays inside of them to store their data. The array really becomes this very common thing. So there's multiple things that you can do in arrays we would love to be able to do on our objects. So having for each iteration, being able to do for each array as key value and just get the data straight out of that. To have direct item access, saying I want element 5 of this array. Or to be able to count, to say how many items are in this array. And these are the things that iterators, ArrayAccess, and Countable are going to provide for you for your objects. So here's this basic mock class we're going to start working on enhancing. And this would be a very similar data access kind of class you might create. A lot of frameworks have something similar to this in there. fact, if you want to look at an example, a framework I helped open source called Treb. It's a little micro framework, and it has a set class that's very similar to this if you go and take a look through it. There's some of this code may or may not have been pulled straight from there for slide purposes. So in this case, we have a class, and we're going to have this protected set. And we're going to have a constructor where we pass in some type of parameters, and then we're going to do sort of a standard cache and load scheme where we're going to try to load the data from the cache. If we couldn't, we're going to load it from the database. Otherwise, we're just going to make the set an empty array, right? And set in this case is always going to be an array. And we have some methods to actually load from cache and load from database. So a fairly straightforward data access kind of layer that if you were storing data in the database, we wanted to have a caching layer on top of it. But now, when you have this, you need a way to actually access that data. And typically, if you'll notice, we did make this set was protected because we didn't want true direct access to that. That's something we want the class to manage. So we need to make a way for someone using this object to be able to access this data. So you might end up doing something like this. And I've seen many code bases where you see exactly this in there. You make a getAll function that just returns the set to you to make it easy to just grab the array out so you can use it. And maybe you make a get that allows you to pass in an index value, and it's just doing an array key exists, looking through the set, returning it, maybe trying to be nice and return null if not, so you're not getting an error if the key didn't exist in the first place. The problem with this is it is a bit of an inelegant solution. Because you end up having code that looks like this. So if you're wanting to get a specific element out, instead of, again, being able to just say, my set number 3, you're having to call this method that you made, my set get, pass in a parameter of 3. And if you're trying to iterate over things, you're going to have to call this getAll function so that it actually returns the raw array to you so that you can then call for each over it. And in the grand scheme of things, yes, if you were able to iterate directly over it, you're just saving that one call. But it's more than that, because part of doing it this way is PHP had to truly return this entire array structure to you for then you to iterate over it one at a time, versus it being able to provide just a single element to you on each iteration. And that if you decided to stop iterating after, say, three iterations, that you didn't have to worry about accessing everything else. One important thing that will come up throughout all of this is that, of course, this is a very simple example that I'm stepping us through to show how to do this. And in the simplest example, some of the stuff may look a little odd. Oh, we're just saving one line there. Why would that matter? But imagine, again, if this is a much more complex example. Imagine if that load from database inside of here wasn't just trying to load the whole thing into an array and save it in the first place, but if it could, on demand, only return the elements you needed. And so being able to iterate over only 3 elements instead of returning the entire array could save a lot of database access or whatever else was needed. So the way that you can natively use for each on your objects is through the use of iterators. And I will drink. So iterator is an interface with 5 methods you need to define to make it work on your object. They all revolve around remembering state, because the idea with an iterator, if you are going to for each over your object has to somehow internally understand where it is within its data set, whatever its data set happens to be. Okay? The data could be anything, but you need to have a way of remembering the state of here's the item I am on, I know what the next item would be, I know what the previous item would be, etc. So the 5 that you need to create are current, which is simply return the current value, key, which needs to return the current value's access key. So again, if you think of this in terms of using an array, it's returning the index of the array. It could be anything. It could be a row number from a database table. It needs to be something you can use to always access that. Next, obviously, moves the internal pointer on to the next item. Rewind should take that internal state and move it all the way back to the beginning. So you can call rewind, then start again. You're getting everything from the beginning again. And valid simply returns whether the internal pointer is at a valid data item. Really, this has one specific use case, which is to know when you've reached the end of the list. Because you'll notice next simply moves to the next item. So if you're at the last item of the list and you call next, next is declared with a void return. Nothing ever checks next return. So if you're at the end, the code calls next to move on. You need to move on past the end of the array, past the end of your data structure. But then, when the next one is, a call to valid will happen before it then calls current to return the value. So as you're iterating over something, it's basically constantly calling valid, then current, then next, then valid, then current, then next, then valid, then current, then next, and it continues through. So if we're using an array as our internal data source, in this case, this set variable, it's actually very, very ridiculously simple to implement this because all of this already exists for an array. We can just reuse all of the array's internal methods because arrays in PHP have the idea of an internal pointer, which you can manipulate by using next and current and key and to walk through an array directly. So you can do this within the PHP. So we're going to extend our previous class. We're now going to implement iterator, and we're going to add in these 5 methods that we needed. So for current, we can just call current, which again, it's a PHP native function and returns the current value of an array. For key, we can call key, exact same thing. For next, we call next. It's getting really complicated. It gets tricky, because for some reason, in iterators, the method name is rewind, but for arrays, it's reset. They do the same thing, though. It moves the pointer back to the beginning. I mess that up every time I go to code this, because I'll just write rewind, and PHP goes, rewind, it's not a valid function. And then for valid, you need to get a little trickier, because again, the idea is that potentially next has been called already on this array. The array is now in an unknown state because it stepped off the end, and you need to be able to detect that. So this little line of code here is sort of the best way I have found to detect this, which is that you try to read the key of the current array, and the key will come back as null if it has moved off the end of the array. So it is valid if the key does not equal to null. And make sure you use strict typing here, because otherwise 0 and null evaluate to the same, and when you're on position 0, it'll end up telling you that you're not valid. I've done that before. So like I said, really, if you're using arrays as your internal structure in the first place, it's actually very simple. You can essentially cut and paste these 5 lines of code into any object you have, implement iterator, if there was an array on the inside, and it now just works. And if you didn't like white space, that could actually collapse down to really, really small and just be a very dense block of code that you could slap into any object. And actually, I'll throw in now that we have traits in the latest versions of PHP, you can actually write this as a trait and use the trait in any object you want to automatically have the trait implement iterator as long as they all use the same variable name. That would be the one to catch there. So, but it'd be a key trick. So now that we've done that, now we can access the object just directly in a for each loop. So we can now declare a new set iteratable and just for each on the object itself. So my set is that object that we had created, and we're just doing for each and asking for key and item, and we get them back directly. And again, at each step through the way, it's calling valid, current, and key. Then it's calling next, valid, current, and key, next, valid, current, key. And when it reaches the very end, because for each loops are very nice for you, for each loops automatically rewind things. So at the end of the loop, it rewinds it, and it's then sitting there ready waiting for you to do another for each loop on it again. So that was how to use your object in a for each loop. So the next step is to try to go in and treat your object like it's an array by using ArrayAccess. So ArrayAccess, again, it's an interface. This time there are 4 methods you need to define. all of these are, again, designed around getting direct key access. Again, it's easiest if you think about this as in our example, that if your internal data is an array in the first place, it's very simple and straightforward. It doesn't have to be. It can be whatever you want. It could be something weird. And I've seen, for example, this implemented where the internal was a MongoDB kind of setup, and these keys were actually MongoDB keys. So by accessing this, it was actually causing queries to go up to MongoDB and return data directly. You can get weird with stuff. So, offset exists is simply the key that has been provided in. It uses the term offset here to mean key. So the offset, the key that was provided, does it even exist in the data? True or false? Offset get, to return the value at that specified key. Offset set, to set the value at that key. And offset unset, to remove that value and key provided. So when you provide the key, both that value and key will be removed. All of these simply take the offset passed in, except for offset set, which of course takes the offset and the value you're wanting to set it to. So again, using the built-in array features, if you're using an array on the inside, it's very easy to build this. So we're actually going to create class set array and extend our set iteratable, and now implement ArrayAccess on it. So for offset exists, we're simply going to use array key exists. It's an equivalent thing at that point. For offset get, well, we're just going to return the value, right? So from this internal array, we're going to return the key that was requested. For offset set, you actually have to get a little trickier here, because there are two things that can happen. If you think about when you're setting values to an array, there are two ways you can set a value. You can use the array's name, bracket, and put an offset in there. So array bracket 3 equals whatever, to say, okay, I want key number 3 of this array to have this value. Or you can do it with an empty set of brackets, to mean just add this to the end of the array. So this code actually has to take care of that. If you try to access it by using the empty bracket notation, then offset comes through as null. Okay? So a simple way to do this is just simply to say if is null offset, then you're actually going to repeat the process here of putting in the empty bracket notation to just add to the end of your array. If it wasn't null, then you're going to go in and just set it directly. So a little bit more than one liner on that one, but it's still very straightforward. And for offset of unset, we're simply using unset. Again, it makes it very straightforward to push these forward, push these through. So now we can completely treat our object as if it was an array. So now we're going to create this new set array. We can directly take our object. Again, my set in this case is an object, but we can use this object as if it was an array. We can say my set, and I want key 3 off of the object, and it will return that to you by calling your method. You can use isSet on it. If isSet, my set Bob, echo Smith. You can also go in and start assigning things. So I can assign to key Eli, white. I can then echo out P, my set Eli. I can then unset it. And you can even use it by putting in arrays. So I'm going to set my set, and again, using blank to just add to the end of the array, this array of years. Then I'm going to add to the end of it this phrase. Again, the idea at this point is you can treat your object completely as if it was an array. Now, something that's interesting to note, you have to implement all 4 of these. But that doesn't mean they have to do anything. So it's a very common practice if, say, you're doing this for data that's come from the database. Maybe you don't want someone calling a set on this data that came from the database, because you're not really going to be setting it. It's meant to be a read-only class of data. You can implement an offset set and offset unset and just have them be blank methods, have them do nothing. You've still validly implemented ArrayAccess. It works. Someone can try to use that direct setting access, but nothing happens. And if you want to be a little more mean, you could implement them so that they throw an exception, or trigger a user error, or whatever else you wanted to make sure to yell at the programmer saying, modifying values in this is not, by direct access is not allowed kind of thing, and throw an exception in there. And for that matter, you don't even have to have your gets do anything normal. You could have, if you're doing a get through this, you don't have to directly return the data. Maybe you're always doing a string reverse on the data and then returning it, or you're doing a rot13. You can do anything you want within those methods. You don't just have to have a very simple return value. So while we're at it, let's implement this final one, which is countable. Countable is the simplest of them all. There is only one method. It's called count. So and all count has to do is count. So we're going to have set countable, extend set array, implements countable. And again, because our set internally here, our underscore set is an array, we're just going to call count on it, because PHP will take care of that for us. And now we're able to directly call. The only thing countable gives you is the ability to call count on that object. You can always call count on an object. However, unless you do this, count will perfectly validly always return 1. There is one object you have asked me to count. So by implementing this, you can tell it how to count. You can tell it how to know what the real value of that object is. And like I was saying, what you return is completely up to you. You could implement count and just return 37 all the time if you just felt like it. You could return a random number. I've actually seen that used to basically make a random number generator within an object. So if you counted the object, it always returned a random number. But it would return a random number that was like plus or minus 5 within what the actual count was. It was this way to I'm trying to remember the use case. It was something where you wanted to be able to give someone an estimate, essentially, of a count, but you didn't want them to know exactly what it was. So the count actually obfuscated it by doing a random plus or minus 5.
Must be marketing.
Yeah, exactly. But in this case, I did it where instead of doing a normal call to count, I added this extra parameter, which a lot of people don't know about. There's a second parameter of an option, and the one option you can give is count recursive, which means it doesn't just count the top level of an array, it will recursively go through the entire array and return what that count was, of how many objects are in the array all the way deep. So you can make your count on your object actually do a recursive count always and make sure you're getting that deeper number out of it, or whatever. So there's another bit of magic. So like I said, the 3 of those to me are sort of the trinity of being able to make your object be used directly as a native type. I almost always try to implement the 3 of those on any object that I create if there is any potential reason to do so. If that object is storing some type of list of data, it will end up having a implements, iterator, ArrayAccess Countable at the end of the object and all of those methods in there. It's just so simple to do. Even if you don't use it, just knowing you could at any point in time. But let's talk about a few others you can do. One is serializable. So is there anyone in here who does not know, and please don't be afraid to raise, but what serialized and unserialized are in PHP? All right. So for those that don't know, PHP has these 2 functions built into it called serialize and unserialize. They take anything, any data structure you have in PHP, an array, an object, anything, and turn it into a text storable, compressed version of that object that you could, for example, store in a database, and then later read that back in and call unserialized on it, and now you have a native PHP object again, or array, or whatever it was, or just string.
It doesn't work on resources, though.
Does not work on resources, and there's something funky about objects sometimes. I'm trying to remember what that is. Oh, if you serialize an object, make sure when you unserialize it that that object has been defined. Because it will simply store it as, yes, here's all this data, and it was an object of type user. If you try to unserialize and don't have type user defined, you get there. And if you've ever used something like memcached, for example, to do caching, this is what memcache is doing. Whenever you say store this object or store this array in memcache, memcache is serializing it to store that in the cache, and when you request it, it's pulling data back and unserializing it to be able to bring it to you. Because obviously, a raw PHP memory sample can't be sent across the wire to memcache. Yeah?
Can memcache serialize an object that hasn't implemented this interface?
Yes.
How?
So the question was if memcache can serialize an object that hasn't implemented this. It can, but all that it can do is remember the name of the object and any public properties. That's it. Basically, it can serialize anything that anywhere the code could see. So again, anything public. So the idea with these is that you can control how memcached will actually cache, or not memcache in this case, but anytime serialize or unserialize is called on your object, you can control what actually gets generated as that serialization, and you can control what gets unserialized as well, or how it gets unserialized. And you do it by implementing these two methods, serialize and unserialize. And here is the very simplest form of this, of course. So in this case, we're doing class set serial, extending set array. Remember, the way we had implemented this, set was a protected value. Normally, a serialize on that would see nothing because it couldn't see the protected value. But we can now tell it that, oh, actually, if someone tries to serialize this object, return a serialized version of that internal set. It's OK that it's protected. I want that to happen. And then to unserialize, you need to provide the reverse logic. So I'm going to unserialize the data that came in and save it into the value of set. Okay? Now, you can do anything you want in there. Actually, yeah, that's the next slide. I'll get to that in a second. Like I said, now serialization works as expected, as you might expect on this. So we can create a new set serial. We can set our, we're going to use our ArrayAccess here to set magazine equals to PHP architect. We're then going to serialize this into an array, into a string. Then we're going to restore it by unserializing it, and then echo out the key magazine. And that code will work. Kind of silly code to do that, but it will work there. What I was going to say is, so we're doing this by just directly calling serialize and unserialize. You can return anything you want there. The only requirement is that you're returning a string. Because that's the idea of serializing, is that it is a text string that can be saved and passed around. So for example, you could use JSON encode and JSON decode and make your objects be actually, when you try to serialize them or unserialize them, have them come out as JSON and have it automatically read the JSON back in to instantiate itself. You could also, again, decide to only save what data you want. So in this case, I've actually created a filter here. What's this actually filter doing? Oh yeah, it's looking through the set, and it's only going to keep items in the set that happen to not be arrays. So if someone put an array inside of the array, it would discard that before it serialized it. And then again, unserialized pulls it back in. So again, you can do whatever you want in here. And I've seen this done with the JSON a number of times, because some people really like JSON and sort of like the idea of storing JSON in the database, for example, so that not only could PHP be reading it back in and unserializing it as JSON, but JavaScript could be accessing it. Other languages all have JSON libraries and could be accessing it. So now, if we put all this together, we get something that looks like this. This is the smacked together onto one slide that just fits. But this is all the code we just looked at. And it's just to go and show how actually small all this code is if you're using an array on the inside and how easy it is to implement this. In all honesty, the most complicated thing is the offset set, because it's having to deal with that whole, was a key actually passed in, or was a day appended to in situation. Everything else is a one-liner. Like I said, you can really get creative with this. I only scraped the surface. There's so much you can go in and do. Nothing needs to return basic information. You can have every single one of these methods return something completely random if you want. It's okay with that. You're going to frustrate every other developer. I've actually seen this used in testing. If you're wanting to test for failures, you can implement some of this and then put in a random number. Like one out of every 100 cases, pretend a database error happened. To be able to do sort of like live load testing. If you know, I want to make sure our system can handle X number of failures happening, and to be able to kind of implement that on the fly. Not saying it's good testing, but that's interesting. All right, so we still have some more time, so I want to go ahead and talk through a few other things here. So first off, I want to talk about magic methods. Does anyone in here not know the underscore get and underscore set magic methods? At least know of them. Yeah. So underscore get and underscore set allow you to have any variable name, any property name be able to be set and read on your object, even if it hadn't been defined already. But with PHP 5, a whole bunch more magic methods were created that allow you to do even more in your object. So I just want to go through a few of these here. So one is toString. It's actually been around for a while, but PHP 5 actually became completely universal. So all of the magic methods, if you're not familiar, all start with double underscore. And you as a programmer should never make something that starts with double underscore. PHP has officially reserved double underscore anything as a possible magic in the future. So you could do triple if you really feel the need. Again, developers will hate you. All right. But toString is simply if you end up using your object in a string context. So for example, you try to echo out your object. If you have defined toString, that's what gets echoed. toString should return a string, and you could have it again. You could have it echo out, "Hi, I'm an object." By default, I believe it actually echoes the word object. If you haven't defined this and you try to echo an object. At some point, I think it started echoing the name of the objects, like user or whatever, user object down. But anyway, you can define what this is at any point. Like in this case, it's actually doing a print R of the entire set if you choose to echo it out. Another is set state. So underscore set underscore state. This is actually called statically. It's a static magic method by var export on your object. So that is, if you've not used var export before, var export takes any object or data structure you have and exports it out as valid PHP code. So that you could export an object, write it out to a file, then include that file, and it now works. It's PHP being able to write PHP. So with set state, you can actually control how PHP writes PHP. So you're basically able, whenever var export gets called, well, let me flip that around actually there. Whenever var export gets called here, all right, we're going to go in here, and again, it gets called statically. So we're going to go in and create a new copy of ourselves, and we're going to set our state to this array that was passed in. Okay, if that makes any sense. The idea is that the way var export works is it's going to echo out this underscore set. You need to be able to put it back into the set when you do the export, and then try to save it back in via an eval. And so you're able to give it this extra code so it understands how to do that. I have it on here because it's funky. I've never seen anyone use this in practice. I'm sure someone has. This one, however, is actually fairly useful. Underscore call has been around for a long time. It allows you to have dynamic methods, just like get and set allow you to have dynamic properties. Well, they added call static. Call static is the same feature, but obviously with static methods. So now you can have your object be able to have any static method called on it, and for you to be able to handle that even if that method had never been defined. So again, just have a couple examples here of this weird function where you can call flip and it does an array reverse. Or you could actually have a call static where if the name passed in was factory, it creates a new copy of itself. There. Okay. Invoke is the weirdest of them all. I've actually seen this used a few times, and every time I see it in practice, it's like, that was an interesting solution you found to that problem. The idea is it allows your object to be treated as a function. So imagine this as declaring __ call, but where you never pass in a method name. You just invoke your object as if it was a function, and magically something happens. What happens magically is that the function __ invoke gets called for you. You're calling it by its own name. You can only make one of these, but it can do anything you want. It can take any number of parameters you want. You're allowed to define that. But you can only make one, so choose wisely. So in this case, like this is actually potentially maybe a valid use case if you had this set type of object I'm talking about here, is maybe you want to make this really shortcut way to slice a section of that array out. So we're going to declare our invoke, ask it for a start and a length. We're then going to return an array slice of the set with that start and length. So now we can instantiate a copy of our object and then just call the object as a function and pass it parameters.
What gets called by default if you don't define invoke? Is it an error?
It's an error. It's trying to call object in function context. This basically allows you to get rid of that error.
I'm most impressed that you remembered the text of the error, actually.
You're assuming I didn't make that up.
I am.
I believe that's actually correct.
Why would you write aloud?
There's my reasons. All right, so now's the time to get you drunk. All right, if beer was involved. So we do still have some more time, so let's go ahead and I want to talk about iterators a little more. With iterators, I talked about how to implement your own. But one of the cool things that the SPL does is it provides this huge library full of iterators that are predefined or iterator helpers that operate on iterators. They're actually called iterators, and an iterator operates on an iterator. Do you understand where the drinking game comes from? So I just want to run through a few of these that are actually useful, because once you have your object acting as an iterator, it's actually, some things become very easy to do in this case. So for example, there's an infinite iterator. And if you declare a new infinite iterator, you pass into it something that is iteratable. So for example, this set full class that we made earlier. And now it means that if you for each over that, that for each will go forever. What infinite iterator does for you is it automatically calls rewind when it gets to the end, so that it never ends. It will just constantly go through. So if you're going to do this, make sure that you stop it somehow. If you like your server, make sure. Actually, as long as there's an execution limit on PHP, you'll just hit the execution limit. But this is a good way if, for example, you were wanting to be able to, like, okay, I need to echo out 100 names of states, even though there's not 100 states. But I just need to fill a list. So I'm going to take my iterator that had names of states, do an infinite iterator, but count to 100, so just 100 things come out. So to make that a little easier, there's also limit iterator. Limit iterator allows you to set a start and a max number of iterations, and it will only iterate that many times. So you can declare a limit iterator of the full set, say start at 0, go to 3, and only items 0 through 3 will come out, which is actually 4 items. Oh no, sorry. Max iteration is 3, so 3 items come out, 0, 1, and 2. But you can start using these together now. So instead of, on that previous slide, I was doing a count and then breaking at 100. But instead, I can wrap a limit iterator around the infinite iterator around our iteratable object. So we're going to declare our object, pass it into a new infinite iterator. Then we're going to for each over a new limit iterator, passing in our infinite iterator, telling it from 0 to 100. And now the limit iterator will iterate over the infinite iterator, which is iterating over your iterator, but it automatically stops at 100.
I'm proud you were able to say all that.
I've practiced.
How do you dependency inject those times?
Moving on. All right, so we've also got filter iterator, which actually just makes it very easy to take something and build a filter onto it. To implement filter, you actually have to extend filter iterator, and then there's one method you need to create, which is accept, which simply should look at your current item and say, return Boolean true or false. Should this item be returned or not? So you can actually build it to skip certain items. So, for example, if you had a list of conference attendees and you wanted to be able to get just the female attendees list out of that, you could create a filter iterator and have it look at the gender field and return true if female, false if male, and end up getting back a list very quickly that way. You do have to use this one funky thing that filter iterator provides, which is called getInnerIterator. Anytime you have an iterator, the iterator stores the inner iterator inside of it, the one it's iterating over, and you have to access that with getInnerIterator. So in the case of accept, to determine this, you have to call getInnerIterator current to get the current value of the innermost iterator. And in this case, I'm just implementing one that says it only returns things if they're arrays, otherwise it skips them. So, to take that one step farther and to actually make it a little easier, there is a regex iterator that simply allows you to give a regular expression, and it will only return things that match the regular expression. So it's actually very simple to use. New regex iterator, you pass in your iteratable object, you pass in your regular expression, and then there's a number of options that you have. You can say return them if they match. You can say return all matches. You can say actually don't just return true, but actually get the matched value and return it. Yeah. You can split on it. You can replace on it. You can use the keys instead, so you can apply the regular expressions to the keys. So this is actually a very powerful thing. And once you've built something that's iteratable, you can very quickly, as long as the items that are inside are just strings, you can very easily create filters to pull out just little bits and pieces that you need. And, yeah?
Does the split return a nested array or an object?
I do not know offhand right now what the split does do.
I'm sure it returns an array.
Oh, yeah. Well, no, actually, what the split does is you will get back more items in your for each loop than there were really items. Because say you had 10 items in there, but each of those may have been CSVs. So now you're going to call split and give it a comma as what it's splitting on. Your for each loop will now return each split piece of each part and then automatically move on to the next one and the next one. So 10 pieces may turn into 100. There is multiple iterator. Multiple iterator allows you to iterate over 2 or more iterators at the exact same time at lockstep with each other. Okay? And it will stop when one of the 2 or 3 run out of items. It then stops. So again, the easiest way to look at this, you create a multiple iterator and you attach different iterators to it. So we create 2 different iterators here. And then when you for each over the multiple, you get back an array. And that array has an item from the first iterator and an item from the second iterator. And each time you step through, you get those locked step. So that can actually be very handy. I've actually used that in production in one case where I had, the way I was getting data back from the database, I had a list of users that were sorted by user ID, and I had a list of users' profile information, which was stored in a separate table because the table got too big, that was also sorted by user ID. So instead of trying to merge those together in memory, I could just read those both in and then iterate over them this way together. And I would always get back both parts of user 1, both parts of user 2, both parts of user 3 as you stepped through it. Here's the part where everyone falls down drunk. because you've got recursive iterator and recursive iterator. And I'm not even going to try. Basically, this allows you to recurse over various items. You define two methods of hasChildren and getChildren. So the idea is that in any step through your iteration, if you put a recursive iterator on top of something, if you implement a recursive iterator, at each step there will be a call of hasChildren, of at this item I am at, are there children or not? If so, it will then call getChildren to get them. And getChildren itself actually needs to return not just the children, but a recursive iterator that can iterate over them. So, and then to actually iterate over your recursive iterator, you have to use a recursive iterator. So you declare your recursive iterator, pass in your recursive iterator, which inside of it has to have an iterator. Yeah.
It gets the innermost iterator.
Right. So in this case, let's say that our set happened to be, instead of it was an array again, maybe there were subarrays at certain points, and we wanted to be able to dive all the way through. This is how you would do that. If implementing hasChildren is array, current the set. If it is an array, there is children. And then you need to pull this children out. There happens to already be an iterator defined called a recursive array iterator, so that you can declare a new recursive array iterator and pass it that inner array, and the whole process will continue. And there's a lot more. This is still just a sampling of them. There are tons of these out there. The directory iterators are really nice. That make it very easy to walk through directory structure on your file system if you're looking for files. You've also got really weird ones like empty iterator, which does exactly what it says on the box. It returns nothing, no matter what.
What's the caching iterator?
Caching iterator is actually, it gives you an extra method you can define for how to cache and retrieve from cache. So the idea is that if you iterate over something once, in the process, it stores those items in cache of some sort. And then the next time you iterate over it, it pulls the items from cache instead of raw accessing the data. So you could actually build a caching iterator over top of your directory or your database access, and have essentially SPL take care of that caching logic for you. And then there's the recursive caching iterator. There's a whole bunch of these. Seekable iterator, parent iterator, callback, recursive callback filter iterator. Yeah. So there are a lot of these different things. So I am out of time.